So hi guys and welcome to a new video. In this video I want to show you how the triangle inequality uh, using the absolute value becomes when using the integer part. So I want first to prove the triangle inequality, and then I will do something similar using the integer part. Okay, so just to remind you, so if u is an arbitrary real number, then we can say that the absolute value of u is always greater than or equal to 0. So the absolute value of u is never negative. And we can say that the square of a real number is equal to the square of the absolute value of the same real number. So we can either put it this way or maybe that way. Okay, so let x and y be two arbitrary real numbers. We can always write that x is less than or equal than the absolute value of x, and that y is less than or equal than the absolute value of y. Now this means that x times y will also be less than or equal to the product of the absolute value of x and the absolute value of y. And if you're wondering how this could happen, well, I mean, the right-hand side is always positive since being the product of two positive numbers, while the left-hand side is either positive or negative, depending on whether x and y have the same sign or opposite signs. So if x and y have the same sign, then both the left-hand side and the right-hand side are equal. And if x and y have opposite signs, then the left-hand side is a negative number, while the right-hand side is a positive number. So this is why this always works. Okay, so now by multiplying the inequality by 2, I will get this. Okay, now by adding to both sides of the inequality x squared plus y squared, so we get this. And notice here that since x squared is equal to the absolute value of x squared, so this is still correct. Okay, and the next step, the left-hand side here is the square of x plus y, and the right-hand side here is the square of the absolute value of x plus the absolute value of y. And now, by taking the square roots of both sides here, so we have the square roots of both sides, and the left-hand side here now becomes the absolute value of x plus y, and the right-hand side becomes the sum of the absolute values of x and y. And thus, we have proved the triangle, the so-called triangle inequality. Okay? And now, let us see how this looks if instead of the absolute value, we have the integer part. Okay, so according to the definition of the integer part, we know that the integer part of x is less than or equal to x, and the integer part of y is less than or equal to y. And this means that if I now add both sides of the inequalities, so I get the sum of the integer part of x and the integer part of y is less than or equal than the sum of x and y. But remember that the left-hand side is an integer. And since the left-hand side is an integer which is less than or equal to x plus y, then according to the definition of the integer part, this integer is less than or equal to the integer part of x plus y, and we are done. So just try to compare now the triangle inequality here and this one using the integer part, and we see that this less than or equal is flipped here. So yeah, this is the difference between the two. Thanks for watching, and see you in the next video. Bye bye.